Somewhere far beyond the noise of planets, beyond the warmth of stars, there exists a silence so complete that even light cannot escape it. Tonight, we journey toward that silence, not with fear, not with urgency, but with curiosity. Black holes have long captured the human imagination. We speak of them as monsters, as cosmic destroyers, as places where everything ends. But what if I told you the universe is rarely so simple? Black holes are not hunters. They do not roam the cosmos in search of victims. They do not chase or devour or rage. They wait. And in their waiting, they quietly shape the structure of the universe itself. To understand a black hole, we must first understand gravity. It's the most familiar force in our lives, yet also the least understood. It pulls apples toward the ground. It keeps the moon bound to Earth. It holds galaxies together across unimaginable distances. But gravity is not merely a pull, it is a distortion. According to Einstein's theory of relativity, mass bends the fabric of space and time itself. The more massive an object is, the deeper the curve it creates. Most objects bend space gently. A planet creates a shallow dip. A star creates a deeper well. But a black hole? A black hole creates a distortion so extreme that space falls inward endlessly. At its center lies something we cannot fully describe, a point of infinite density known as a singularity. Around it exists a boundary, an invisible threshold, a point beyond which nothing can return. This boundary is called the event horizon. The event horizon is not a wall. It is not solid. You would not feel it as you crossed, but once crossed, the universe behind you would be forever unreachable. Not even light, the fastest thing that exists, can escape once it is past this point. And without light, there is no image, no reflection, no information. This is why black holes appear black, not because they consume light actively, but because they allow none to return. Black holes do not appear suddenly. They are born from patience, from balance, from time. Long before a black hole exists, there is a star. A star is a delicate negotiation between opposing forces. Gravity pulls inward, trying to crush the star under its own weight, while nuclear fusion in the star's core pushes outward, releasing vast amounts of energy. For millions or even billions of years, these forces remain in balance, and the star shines. But fuel is finite. Eventually, the nuclear reactions slow. The outward pressure weakens, and gravity begins to win. For smaller stars, this collapse ends gently. They shed their outer layers and fade into white dwarfs. But for massive stars, those many times heavier than our Sun, the ending is far more dramatic. When fusion finally stops, gravity causes the core to collapse in less than a second. The star explodes outward in a supernova, briefly shining brighter than an entire galaxy. What remains behind depends on mass. If the core is heavy enough, not even neutron pressure can resist the collapse. Space itself gives way, and a black hole is born. There is no moment of announcement, no cosmic signal that says, "Here, something extraordinary has begun." The universe does not celebrate. It does not pause. A black hole simply exists where a star once shined. From far away, a black hole behaves like any other object with mass. Planets could orbit it. Stars could pass nearby. Nothing about it appears dangerous. Only when something comes too close does the difference become clear. As matter falls inward, it heats up and accelerates. An accretion disk forms, a glowing ring of gas and dust spiraling toward darkness. This light is often the only sign that a black hole is present at all. Without it, black holes would be almost impossible to detect. They do not shine, they do not reflect, they announce themselves only through gravity. Imagine drifting toward a black hole. From your perspective, nothing feels strange at first. The stars behind you still shine. Your thoughts still flow normally. Time feels unchanged. But for an observer far away, something remarkable begins to happen. As you approach the event horizon, your movement appears to slow. Your image stretches. Your signals take longer to arrive. From their point of view, you never quite cross the threshold. You simply fade. But from your own perspective, time continues. You cross the event horizon without fanfare, and beyond it, the rules change. Inside a black hole, all paths lead inward, not because of force, but because of geometry. Just as you cannot move backward in time, you cannot move outward in space. The singularity lies in your future as surely as tomorrow lies ahead of today. As you fall deeper, gravity becomes uneven. The pull on your feet grows stronger than the pull on your head. This difference stretches you. Physicists call this spaghettification. It sounds humorous, but the reality is quiet and absolute. There is no sudden tearing, no violent explosion, only an increasing tension as space itself is pulled longer and thinner. For smaller black holes, this stretching would occur quickly. For supermassive black holes, it could take much longer. In some cases, you might cross the event horizon without feeling anything at all. The universe does not always announce when you have passed a point of no return. Near a black hole, time does not behave as it does on Earth. The stronger the gravity, the slower time flows. This has been measured experimentally. Clocks placed in stronger gravitational fields tick more slowly than those farther away. Near a black hole, this effect becomes extreme. Time stretches, a moment becomes an eternity. Near the event horizon, time nearly stops relative to the outside universe. This creates a strange divide, two realities unfolding at different speeds. For the universe outside, billions of years may pass. Inside, only moments. This is not because time ends, but because it bends so deeply that it folds in on itself. At the center of almost every galaxy lies a supermassive black hole. These giants are not formed by collapsing stars alone. They grow slowly, feeding on matter, merging with others of their kind. Our own galaxy, the Milky Way, is anchored by one, Sagittarius A star. It is more than 4 million times the mass of our Sun, and yet it is smaller than the orbit of Mercury. Its gravity holds the galaxy together, guiding the motion of billions of stars. Without it, the Milky Way might never have formed. Black holes are not merely destroyers, they are architects. There are black holes so enormous that they defy ordinary comprehension. They lurk at the centers of galaxies, hidden behind the swirling dance of stars, gas, and dust. These supermassive black holes weigh millions or even billions of times more than our Sun. They are not born from a single star, but from the slow accumulation of matter over eons. Gravity gathers gas, dust, and sometimes smaller black holes, feeding them into a dense core where time itself bends. Some of these giants anchor their galaxies, holding billions of stars in a delicate gravitational embrace. Sagittarius A star at the center of our Milky Way is one such presence, quiet yet commanding. From our perspective on Earth, it is invisible, silent, and undetectable to our senses, yet its gravitational pull is ever present, guiding the motions of stars in a slow cosmic dance. The black hole is both a destroyer and a creator, feeding and shaping the environment around it. Matter that drifts too close begins to spiral inward, forming an accretion disk that glows with the heat of friction and compression. This light, bright and swirling, often becomes the only signal that a black hole exists at all. Yet the majority of the mass remains hidden behind the event horizon, unseen, unknowable, silent. Some black holes release energy in dramatic jets that extend for thousands of light years, carving paths through the surrounding interstellar medium. These jets are narrow and precise, moving close to the speed of light, sculpting gas clouds and triggering the formation of new stars far away from the black hole itself. In this way, the black hole participates in creation even as it consumes. It is a paradox, a reminder that destruction and formation are intertwined in the universe. The greater the mass of the black hole, the deeper the curvature of space and time around it. Clocks move slower, light bends. Paths that once seemed linear now curve toward the singularity. Time and space, the familiar scaffolding of the universe, become strange and distorted. A photon of light passing near a black hole can orbit it many times before escaping, tracing invisible spirals that take years to complete. For an outside observer, this light takes on a strange, stretched quality. Time dilation means that events near the event horizon appear to slow almost to a stop. From afar, a star collapsing into a black hole seems to freeze in its final moments, lingering on the edge forever. Yet, from the perspective of the falling star, time continues normally, each second as vivid as the last. This discrepancy is not merely theoretical. It has been measured in weaker gravitational fields closer to Earth, where clocks on satellites tick faster than those on the planet's surface. Gravity does not just bend space, it bends time. And near a black hole, this bending reaches its extreme, revealing a universe far stranger than our everyday experiences allow. Matter falling into a black hole is stretched and compressed. The closer it gets, the more severe the stretching. For stellar mass black holes, this process can tear atoms apart in a fraction of a second. For supermassive black holes, the stretch is more subtle, allowing objects to cross the event horizon without immediate destruction. Even so, Once crossed, there is no turning back. Every trajectory points inward. Every path leads toward the singularity. There is no rescue. There is only the slow, inevitable convergence at the center, where density and curvature become infinite. It is a place where physics as we know it fails, where the familiar equations of motion and energy break down. The singularity is not just an endpoint, it is a threshold into the unknown. Scientists speculate, calculate, and imagine, yet no observation has ever revealed its true nature. We can only infer its presence from the effects on the surrounding space. Despite the darkness, black holes are luminous in another sense. The energy released in the process of matter falling inward is enormous. A small amount of mass can radiate as much energy as 1 billion suns. Quasars, the most brilliant objects in the universe, are powered by these extreme processes. A quasar can outshine its entire galaxy, yet its source is hidden behind the event horizon. The brilliance we see is not the black hole itself, but the matter dancing in its grip, heating to millions of degrees, spiraling in a perfect, perilous orbit. Some black holes spin at astonishing speeds, twisting space-time itself in a phenomenon known as frame dragging. Space is not merely curved near these black holes, it is twisted, dragged along by the rotation of the singularity. In this swirling, warped environment, nothing moves in straight lines. Orbits are elliptical and unstable. Paths that would seem impossible on Earth become natural here. Gravity waves ripple outward from these events, disturbances in the fabric of space-time itself. These waves, predicted by Einstein and observed only in the last decade, carry information about black holes colliding, merging, and growing. They are faint, delicate, and yet they traverse the universe at the speed of light, arriving in our detectors billions of years after the event occurred. When two black holes collide, the resulting object is more massive, larger, and capable of greater influence. The process releases a burst of gravitational waves that spreads across the cosmos, a silent echo of violent interaction. Yet to any nearby observer, the collision appears almost serene, a merging of darkness and gravity without the dramatic noise we might imagine. Black holes are patient. They wait, they feed, they merge. They shape the universe quietly, invisibly, over timescales that dwarf the human imagination. Even the light escaping from near a black hole can be delayed, bent, and lensed by gravity. When we observe distant black holes, we see them not as they are now, but as they were millions or billions of years ago. The information reaching our eyes is always old, always a reflection of the past. Time near black holes is fluid, elastic, and profoundly non-linear. Some theories suggest that inside a black hole, the singularity may branch into new universes, tiny pockets of space-time that expand independently. These ideas are speculative, mathematical, but they offer a glimpse into the depth of mystery surrounding black holes. If one considers the universe as a book, black holes are the pages we cannot read. They contain history, matter, energy, and perhaps the seeds of other realities. yet they remain unreadable from the outside. Stephen Hawking showed that black holes are not entirely eternal. Quantum effects at the event horizon slowly release energy. This Hawking radiation is faint, almost imperceptible, yet over unimaginable spans of time, it leads to evaporation. Black holes, even the supermassive giants, are not permanent. In the far future, when stars have burned out and galaxies drift apart, the universe will be dominated by black holes. They will persist long after light and warmth have vanished from ordinary space. And then, over trillions upon trillions of years, they too will fade into nothing, leaving the universe cold, silent, and empty. Yet even in this ultimate darkness, the cosmos remains beautiful. The paths of stars, the curvature of space, the remnants of galaxies, all testify to the passage of time, to the influence of gravity, to the delicate balance of creation and destruction. Black holes are not monsters in the sense of malice or intent. They are forces, they are geometry, they are destiny made visible. To contemplate a black hole is to contemplate infinity, to consider how deeply the universe can bend, and to feel the fragility of human perception in the face of cosmic scales. And yet, we are part of this story. The atoms in our bodies were forged in stars, some of which may have been consumed by black holes long ago. Gravity that shaped our galaxy shaped us as well. There is a connection, subtle and profound, between the immense and the intimate. As you imagine drifting past a black hole, consider the silence that surrounds it. There is no sound in space, no roar, no scream. The universe does not announce the birth of a black hole, nor its final evaporation. It moves on quietly, carrying the weight of billions of years in each photon, each particle, each whisper of gravity. The universe is patient, and in its patience, it teaches. There is balance in creation and destruction, in light and dark, in existence and disappearance. Black holes are reminders of this balance. They are teachers, not tyrants. They are architects of galaxies, sculptors of matter, guardians of cosmic time. And even as they fade, their influence remains imprinted on the structure of the universe, in the orbits of stars, in the lingering glow of galaxies, in the gravitational waves that ripple silently across space. To look at a black hole is to peer into a place where our understanding ends, and yet imagination begins. It is to recognize the vastness of the cosmos, the fragility of our experience, and the enduring mystery that surrounds us. Even the largest black holes, despite their apparent permanence, are not truly eternal. Quantum mechanics whispers its presence even at the edge of these cosmic giants. At the event horizon, particles and antiparticles spontaneously appear and vanish, fleeting as shadows, ephemeral as thoughts. Occasionally, one particle escapes while its twin falls inward, and the black hole loses a tiny fraction of its mass. This is Hawking radiation. It is slow, almost imperceptible, yet over unimaginable spans of time, it causes even the most massive black holes to shrink. The process is not violent. There is no explosion, no dramatic spectacle. It is the quietest form of undoing, a patient undoing of gravity's work. In this, black holes teach us that nothing in the universe is truly permanent. Time stretches and contracts, stars shine and fade, and the universe itself evolves with a rhythm far beyond human comprehension. Consider a black hole with the mass of the Sun. Its Hawking radiation would take far longer than the current age of the universe to evaporate entirely. But a supermassive black hole, millions of times more massive, would endure for trillions of years, patiently radiating its energy into the cosmos, slowly letting go of what it had claimed. And in this slow disappearance, the universe moves toward an ultimate state. Long after galaxies have drifted apart, after stars have burned out and cooled into cold remnants, black holes remain. They are the last reservoirs of matter, the final keepers of energy. The universe grows quiet. The background light dims. The cosmic microwave glow fades to near nothing. Space stretches further as expansion carries everything apart, and time stretches almost endlessly. In this silent eternity, black holes slowly evaporate, leaving behind a universe of near-perfect emptiness, a cosmos almost entirely dark and cold, where energy exists only as diffuse radiation scattered across infinite distances. And yet, even in this far future, the universe is not meaningless. Each black hole in its life and quiet death shaped the cosmos. Their influence is encoded in the structure of galaxies, in the orbits of stars long gone, in the gravitational waves that once rippled across space. They leave behind patterns, echoes, and traces of everything they touched. The universe remembers, even when no observers remain. As we imagine this distant epoch, time takes on a new quality. A single moment stretches across millions of years, and yet still the black holes persist, slow, deliberate, almost patient. The fading of a black hole is a meditation on impermanence. It is a reminder that even the strongest, densest, most seemingly eternal objects are subject to the passage of time. The cosmos itself becomes a mirror of this truth. In contemplating black holes, we are not merely studying matter or gravity. We are studying time, existence, and change. We are reminded of our own place in the vastness, our own impermanence, and yet our own connection to the cosmos. The atoms within us, forged in ancient stars, once danced near black holes themselves. The calcium in our bones, the iron in our blood, the oxygen we breathe, all are remnants of a universe that shaped itself through cycles of creation and destruction, through the quiet work of gravity and fusion, through stars that lived and died long before humans existed. The universe is patient. Black holes are patient, and in their patient, silent ways, they sculpt everything around them. They are the ultimate teachers of scale, of time, of the subtle balance between creation and destruction. Imagine drifting in space near a supermassive black hole. The stars around you shimmer with familiar light, yet you can feel the subtle curvature of space, the slow bending of time, the faint tug of gravity stretching the universe itself. There is no fear, no danger, only the quiet realization of how immense and precise the cosmos is. The light of distant galaxies may appear distorted, stretched into arcs by the black hole's gravity. The nearest stars may seem frozen in place, their motions slowed by the time dilation that bends reality near the event horizon. And if you were to fall inward, crossing the boundary, you would do so without fanfare. Time would continue for you. For the universe outside, you might appear frozen indefinitely. And as you approach the singularity, space itself stretches and compresses, every direction leading inexorably inward. The singularity is not a point of malevolence. It is a limit, a boundary of knowledge, a place where our understanding falters. Physics, as we know it, no longer applies. Yet even here, in this extreme environment, there is elegance. The equations of general relativity bend and twist, revealing the unity of space, time, and gravity. It is a cosmic choreography of immense power and subtle beauty. Consider the philosophical weight of this. To imagine an object that bends space and time to such extremes is to confront the limits of human comprehension. To recognize that matter, energy, and even time itself can be warped so profoundly is to experience awe in its purest form. Black holes are reminders that the universe is larger than our senses, deeper than our instruments, and stranger than our imaginations. Yet they also remind us of continuity. They connect past, present, and future. The gravity that shaped stars and galaxies billions of years ago continues to act today, guiding motion, shaping structure, influencing formation. Even after the black hole has evaporated, its effects persist, encoded in the fabric of the universe, in the orbits of distant remnants, in the distribution of cosmic radiation. And so we learn from black holes about patience, impermanence, and subtlety. The universe does not rush. The processes that shape it unfold over incomprehensible timescales. Stars live millions of years, galaxies evolve over billions, black holes persist for trillions, and their evaporation stretches even beyond that. Human life is a fleeting moment against this canvas, yet the same forces that govern black holes govern the atoms in our bodies, the orbit of the moon, and the light that reaches our eyes. There is a profound unity in this realization. You are made of the same material, shaped by the same forces that govern the darkest, most extreme places in the cosmos. And as we contemplate the distant future, when the universe is quiet, empty, and dark, there is still beauty. The silence itself is meaningful. There is a rhythm in emptiness, a pattern in what remains, a continuity in time and space. Even in the cold, fading universe, the story of creation, growth, and decay continues, encoded in the geometry of space-time, the paths of vanished stars, and the lingering influence of vanished black holes. To study black holes is to study endings, but also beginnings. They are the architects of galaxies, the keepers of matter, the sculptors of light and time. In their quiet, patient way, they teach us about balance. Creation cannot exist without destruction. Light emerges from darkness. Order arises from chaos. And even when the black hole has vanished, the universe retains its imprint, its memory, its subtle structure. Consider this as you drift through thought, as you imagine floating in space, as your mind travels along the curvatures of space-time. There is calm in understanding, wonder in knowledge, serenity in accepting scale. Black holes, immense and silent, remind us of our own fleeting existence and our deep connection to the cosmos. Their patient influence continues to resonate across space and time. Even as they fade, the universe carries on, shaped by the forces they once exerted. And as you let yourself drift with these thoughts, you may feel a profound connection, not only to the universe as it is, but to the vast, silent, elegant processes that have been unfolding since the beginning of time and will continue long after every star has faded. In contemplating black holes, we contemplate infinity, mortality, and continuity simultaneously. We see the universe as it truly is, vast, slow, patient, and full of quiet wonder. There is no need to rush, no need to fear, no need to comprehend fully. It is enough to observe, to imagine, to exist as part of this grand, unfolding cosmos. Imagine the universe at its quietest, long after the last star has faded, long after galaxies have drifted apart, when the sky is black and the cosmic microwave glow has thinned into near nothing. Even here, black holes remain, the final keepers of matter, slowly releasing their energy through Hawking radiation, shrinking imperceptibly over spans of time beyond human imagination. The universe grows cold, silence dominates, time stretches endlessly. And yet, even in this emptiness, there is beauty, for the structure of the cosmos still bears the fingerprints of what once was. Galaxies that have dispersed leave traces of their former shape. Gravitational waves ripple across empty space. The energy released by black holes, the light that once escaped from accretion disks, the remnants of matter that circled them, all persist in subtle ways, carrying the story of existence forward. There is a rhythm to this quiet universe, a slow pulse in the void, a pattern in absence. Even when the ultimate darkness descends, the universe is still a living thing in its own way. The atoms that make up your body, the molecules that form your thoughts, were shaped in part by stars that died, by matter that once spun near black holes, by the quiet dance of gravity and time. You are connected to all of it. Every black hole, every galaxy, every photon that ever traveled the cosmos is part of the same narrative that continues within you. And as you contemplate this, let the vastness of space calm you. Let the incomprehensible scales of time remind you that your worries, your fears, your urgency are brief and small. There is patience in the universe. There is continuity. There is order. Black holes teach this in their silent, invisible way. They are not destruction for destruction's sake. They are forces of balance, sculpting, shaping, guiding. They organize galaxies. They trigger star formation. They release energy that lights the cosmos. They bend space and time to reveal the extraordinary flexibility of reality itself. Imagine floating near a black hole in thought, not falling, not fearing, but observing. See the light around the accretion disk swirl slowly, the jets of particles extending across empty space, the distant stars frozen in time by the stretching of gravity. Hear the silence, sense the stillness, understand that in the vastness there is no hurry. The universe moves with deliberation. Stars live and die in their own time. Black holes persist in their patient way. Energy flows, matter circulates, time bends, and all of it unfolds without urgency. Even the final evaporation of black holes, taking trillions upon trillions of years, occurs without fanfare. It is the quietest event imaginable, a gentle fading of mass into radiation, a soft closing of a chapter written over cosmic eons. And yet, even in this fading, the universe does not lose beauty. The structures created by gravity, the orbits, the patterns of matter, the subtle bends in spacetime, all persist as testimony to what has occurred. And so you can imagine this as a reflection of life itself. Nothing is permanent. Everything changes. Everything evolves. Even the seemingly eternal is subject to slow transformation. And within this understanding, there is peace. Let yourself drift along with these thoughts, letting gravity and time fold gently around you in imagination. There is no rush to comprehend fully, no need to grasp all details. Allow yourself simply to float, to feel the scale, to sense the patience of the cosmos. Black holes are not enemies, they are teachers. They are reminders that creation and destruction are inseparable, that light emerges from darkness, that order can arise from apparent chaos. Even when nothing remains, the universe carries the story forward in the patterns that persist. And as you reflect on this, allow your mind to quiet. Let each breath become as slow as the movement of a black hole in space. Let each thought drift like a photon, stretching and bending in the curvature of your awareness. Imagine time slowing. Imagine space stretching. Imagine the infinity that surrounds you, yet feel safe, embraced by the rhythm of existence itself. There is wonder in this. There is calm. There is serenity. Black holes, in their patient silence, guide your attention to what is essential: the flow of time, the dance of matter and energy, the enduring beauty of existence. Let your imagination drift through galaxies long gone, through stars that have burned to ash, through the empty spaces between. Feel the quiet elegance of the universe, the symmetry, the balance, the slow unfolding of cosmic events. You are part of this story, not separate from it. The same forces that shaped black holes shaped you. The same atoms that were once pulled into distant singularities now exist within you. The same energy that flowed through stars now flows through your body. In this awareness, there is connection, continuity, and peace. The universe is patient. You are patient. All is unfolding as it should, without haste, without interruption. And as you let yourself float in this cosmic calm, let the darkness of black holes be a comfort rather than a threat. Let the silent curvature of space be a lullaby. Let the slow fading of even the greatest, most massive black holes remind you of impermanence, of transformation, of the subtle beauty in every ending. And when the final black holes vanish, when the universe is nearly empty, let your thoughts linger on what remains, the memory of structure, the trace of energy, the quiet imprint of matter. Let this be enough. Let this vastness settle into your mind as a gentle meditation. Let the scales of space and time stretch and bend in your imagination, carrying you through silent galaxies, past ancient stars, and toward a horizon without end. And now, in this place of calm, let your breathing match the slow rhythm of the cosmos. Let your mind align with the gentle pulse of the universe. There is no need for words, no need for action, no need for urgency. Simply exist, simply observe, simply be. The black holes have taught their lesson: patience, impermanence, continuity, and quiet wonder. Let this knowledge sink in, let it surround you, let it carry you forward as the universe continues its silent dance, as the stars fade, as black holes shrink, as time stretches, as infinity unfolds. And remember that you are part of this cosmic story, connected to everything that was, is, and ever will be. A single note in the symphony of the universe, a moment of consciousness floating in endless space and time, held gently by the patient, quiet, eternal gravity of all that exists.